Tresa Motors happen to be making automotive products right now. But the reason Tresa Motors exists is because there are sort of unhappiness about a lot of things. For example, the language I'm using with you is not ours. The phone and the communication software that we're using right now to talk to each other is not ours. When I say ours, I'm talking about India.
Hello, viewers and tech enthusiasts. I am Hardik Narula from EV Tech News powered by Motor India. And today we have with us Mr. Rohan Shravan, who's the founder and CEO of Tresa Motors. And Tresa Motors is trying to revolutionize transportation and through safety, innovation, and sustainability. And we'll go deeper into that today. So, before we start talking about Tresa Motors as a company, let's start with you as an individual, Rohan. Why we'd like to know more about why you decided to start Tresa Motors. What was your motivation, passion behind it?
Yeah, so hello everyone and hello Adik. First of all, since childhood, I've been collecting cars, photographs of cars, and as much as possible. Then Wikipedia came in, and I was very sad because I had huge collection of all the possible cutouts from magazines which I used to collect. So, being a fan since beginning, I'm a mechanical engineer from IIT Kharagpur. Also, wanted to do something on the mechanical engineering side, but took a my first company was not into automobile. Our first company was into electronics because there was one specific problem which I wanted to solve, which is we are dependent on machines. I wanted to get rid of that part. So my BTech project was in computer science, even though I was from mechanical engineer and it was in AI. We were doing face recognition, and then for mechanical, I did screw and some defect detection as well. But during my first company, what I realized is that even though the product did really good, NVIDIA came back and said that we can't give you the processor because we're exclusive to Motorola. And Google said that they can't give Android because we're exclusive to Motorola. Motorola was bought by Google and they launched their own tablet called Zoom at that time. The biggest learning was that unless you have the IP in-house, don't start. You might be an OEM for good days, but after that, someone can just pull the plug. So since 14, it took around 6, 7 years to get the motor right. And finally, when we got our team last year, a brilliant team on the motor design, and that's what actually has started a journey for us. And specifically, why we started with trucks is essentially there are 3% in total numbers, but they cause 60% of pollution, 40% of carbon dioxide, monoxide, and it's a big segment. We can't say that we are selling millions of scooters, but not target the main battle, which is the trucks right now. If you are able to take all the trucks off the ground, then that's a Paris Convention agreement that we have signed up that we'll be very happy about closing faster. So that's all. In future, we will do something special after trucks also, but right now focuses on trucks and getting them right. And logistics, if you think about it, is the backbone of a country. If we are succeeding in logistics, then the whole country GDP also gets affected.
Great. So I guess the seed for you to be an entrepreneur in this space was planted way back when you were a child.
Since childhood,
Started with
I've been
yeah.
making toy cars, and the design that you see in the background is not inspired by Teslas. Everyone keeps asking me. I designed this in 2014, and
Okay.
then my wife improved this further on, and that's where it's coming. It's not inspired. The design looks like this because we wanted to go low on tooling. Now this design allows us
Right.
to do something called laser cut and then build a space frame. So it's on the cost benefits and overall aerodynamics that we picked this.
Right. Um, so for our viewers who are probably like in school and maybe in college, why do you? I mean, let's just come to why Tresa Motors exists and what is the goals that you guys are looking at and what's the purpose. Just a quick introduction to what the company is trying to do.
Yeah, so Tresa Motors happen to be making automotive products right now. But the reason Tresa Motors exists is because there are sort of unhappiness about a lot of things. For example, the language I'm using with you is not ours. The phone and the communication software that we're using right now to talk to each other is not ours. When I say ours, I'm talking about India. With the largest population in the country, we have not seen products which can go globally, and we probably can say that, okay, this is made in India and this is designed in India. Even though right now you can see that EV market is picking up, if you actually go on the component level, we are still buying from China or Germany or some other supplier. So we've not built that ecosystem, and that doesn't feel to be something about proud of. I'm proud about. Tresa Motors exists to take India to the next level. That's why we're adamant on making things that we innovate. Whatever is already there and stabilized in the market, and we can't innovate, it doesn't make sense to invent a circle again. So Tresa Motors exists to make sure that Indians are not known as really good Indians outside the country as CEOs of big companies, but also for the products that we can make here and sell outside the country. And if you're in school, then just believe in yourself. You can do anything you want.
So I want to ask you, do you how fast do you think we can replace electric trucks, ICE trucks with electric, and can we completely replace them, or is it going to be, a partnership where we slowly reduce adoption, and then what do you feel about that?
So, if you think about the big OEMs, they have massive investments in the ICE infrastructure right now. And the last couple of years, there have been announcement on using some other fuels. It might be ethanol, it might be LPG, it might be CNG. So there are efforts in keeping the ICE industry alive because same components get used. There are a lot of challenges for EV, especially on the energy and charging infrastructure point of view. And then there is no OEM in India which is using products which are made in India because they're not designed in India. If you want to buy, let's say, high performance or a high duty electric motor in the country, with respect to global standards, we are not there. Neither on the battery pack. There are good companies in India, but they are essentially buying from China or equivalent markets and selling it. So it's going to take a bit of while. My expectation is that somewhere around 4 to 5 years is before we start seeing the tipping point, but it's going to move very fast. The reason we move very fast is because we Indians love one specific thing, and we ask that question, "Kitna deti hai?" And electric vehicles really good on the overall mileage and the cost per kilometer. So the moment it's like a blood to the teeth of a tiger. So the moment logistics guys understand that there are economic benefits also on moving to trucks, it will just scale up. Government has to help in terms of the charging network. Companies like us and other OEMs will have to invest on setting up the initial charging networks, and then it can be managed by the people or the fleet owners.
Right. So you mentioned a little bit about the design before. So let's go a little deeper into that. You said that people think that it is inspired by the Cybertruck. Honestly, when I saw the truck for the first time, could see a similar design language, but like you said, it's not. You started way back in 2014, and the reason for the design to be like that is for manufacturing ease and aerodynamics. Could you go a little deeper into that?
Yes. So every time you have seen a curved surface on a steel, it's made through a process called stamping. And stamping requires tooling, which means I'm going to take a very high density steel. I'm going to CNC that and get perfect shape I'm looking at, then take steel and stamp the hell out of it. These tools are very expensive. Just to make a cabin curved and adding a degree of, let's say, complexity over the whole design, we might end up spending something like 200 to 300 crore just on the tooling side. And
Hmm.
when we go what we have done in that particular direction, now we can do a laser cut of the steel and then add internal structures to make sure that the tooling is not required as much as it will be required in case of a, let's say, curved body. And on top of that, most of the trucks you're going to see in the country, they are flat faced, right? You don't see the overall angle, which can help with respect to the aerodynamic performance. Because till now, because we are on diesel trucks, aerodynamic was never a problem. You're spending let's say 18 rupee per kilometer, 28 rupee per kilometer. If it is 29 because of bad aerodynamic, that didn't matter a lot. But for electric vehicles, that's a big concern because every ounce of efficiency that we can take out is going to help the battery. That makes us sell a more affordable truck because now less battery is required. So it has a cascading effect. Now the truck is also lighter, for which I also need less battery. So it has much bigger effect with respect to the aerodynamics. And if you see the angle itself, the angle of attack
Hmm.
of what we have done, the top portion allows us to get the aerodynamic efficiency. The bottom portion is designed to get as much air as possible into the radiators, which are required to cool the battery pack, cool the motors, and make sure that everything is optimized for the temperature, the working temperature.
Okay. So what about, I mean, the design seems quite sharp, like it has a lot of sharp edges. And normally with aerodynamics, you want smooth surfaces, right? For the uh, flow to be laminar. So do those edges add to the complexity of the aerodynamics, or um,
You might remember one of the Mark II stealth aircraft from US. It is all edgy. It looks like a triangle. So there are ways to work with the corners also, but yeah, you're right.
Okay.
It is sharp, and the reason we don't want sharp edges is because of the pedestrian safety. That's goal number one for us.
Mm.
So the
Mm.
design you're seeing is the engineering prototype design, and it is under the simulations. And as we are going to evolve, there's a reason it's called Model V01.
Right.
So the moment you're going to see Model V02, you're going to see, oh, there's an update, a Model 3 will update, and it's going to come back from the on-field trials and data and how safe it is for the pedestrians and how good are we on the efficiency. So the whole design is going to be governed by the overall engineering factors.
Okay. So by having this design, why do you like? What do you think is the number in terms of percentage of efficiency improve compared to a normal truck?
Yeah, so normal trucks generally have the aerodynamic drag of somewhere around 1.2 to 1.8.
Okay.
We are at zero point 0.7 already, and we are trying
Okay.
to get it down to zero point 0.6. If it was a car, then it's easier because you can take the front glass as back as possible. You can hit zero point 0.2, zero point 0.3, but in trucks, we are trying to see if we can do the best.
Okay. And the second thing that your company talks a lot about is the axial flux motors. Can we get into that? How is it different from radial flux motors, and uh, why is it so much better?
Okay, so first thing is radial flux motors are heavy. And the reason they're heavy is because the magnet sits on the radii of the motor. So if you imagine a cylinder, the magnets are on the perimeter of the body. And now you have the copper rotating inside or the rotor magnet rotating outside. That can depend on design. But when you now you want to integrate or make the magnets interact with the copper, the magnets are like this, and the copper is below. So the magnetic field has to go in, and that's the only way it goes in. There's no way you can go out, right? So it's not finishing a loop. Whereas if you think about what we're doing is that our motors, let's say this is a cylinder, our motors on the side, parallel to the axis. So one magnet here starts the magnetic field, ends at the next magnet. So the density of magnetic field inside a axial flux motor is way higher compared to a radial flux motor. So magnets just get used more. It can be electromagnet also. It's not just on the magnetic side. So the electromagnetic loops are very short, very concise, and the very short distance they have to travel. Our motor is literally like a auto tire, probably. That's the size. That's how thin it is. 72 mm or 76 mm with
Mm.
extra components. So that's the only length the magnetic field has to cross. And the loop gets closed because of design. So just behind the magnets, we have more electromagnetic elements which take the magnetic field, rotate it 90 degree, and push it back from the next magnet. So because of very, very high dense magnetic field, axial flux motors are really good. Now, second benefit is our motors are at 800 volt. Other motors, radial flux motors, mostly in the company and in the country and from nearly all the OEMs are going to be at 400 volt. That means I draw half the current for the same power. That means the magnetic or any other, for instance, the heat loss is going to be one fourth. It's a square. So that's the
Right.
main benefit that we get. High, extremely high voltage, really good cooling, and the high magnetic density.
Why is it that other manufacturers have not really explored axial motors in India all that much in comparison to radial flux motors?
Not only India, in world there are around 10 to 12 manufacturers of axial flux motors, and we happen to be one of them. So for small motors, Indian companies have started. I've heard some news in the media that there are companies working on this. So in the world, it's actually pretty low. And the reason is that these motors are extremely difficult to control. So controller is the most difficult part. So you
Mm.
now imagine that we have a voltage controller or motor inverter, which is working at plus 800, minus 800 turned into AC voltage, and then pumping 450 amps at 14,000 hertz per second. So driving a controller
Mm.
like that is very, very hard. And to keep the controller efficiency high, we have to use something called silicon carbide MOSFETs. So these are also very expensive. But because we have now indigenized the design, the whole thing works far more effective and efficient for us and cheaper also compared to the motors. So Daimler bought a company called Yasa Motors last year. Probably, I'm not sure on the timing, but now their AMG cars are using axial flux motors and motor performance are really good. That's why now more people are looking at it. And in India, if I ask you a question, who makes a motor, you will not find a lot of answer. There's a company which says on electric, buying motor from Volkswagen. The largest OEM for the electric cars in India has a Indian factory where they assemble the motor, but the parts come from China. So if you see that there is really no ecosystem on on the scooter side also, either you're buying from Bosch or you're taking from China. So component ecosystem is not adopted yet.
Yeah. So even when we start manufacturing, like you guys have designed the motor from scratch, right? So the components like the magnets and everything, there are no suppliers in India, right? So you have to rely on import for that, isn't it?
That's
At
correct.
least initially.
That's correct. India has, and you'll be surprised to know, India has a really good amount of rare earth raw material mines which can be used. But again, the ecosystem is not developed yet. So we are hoping that in few years we'll have these things available in India as well. And now we have Australia also fighting for the same place for the rare earth. Australia also have a lot of material, but it will need to be imported for quite some time.
Okay. Can we move on to the next technology that differentiates Tresa is the e-axle that's been
Yes.
mentioned. So
Yes.
let's talk about that.
Okay. Now, if you see what other people are doing it, and it will be their strategy for some time to come, you take the engine out of a truck and put an electric motor inside, and things become easy. You don't have to think about the gearbox and other stuff. But now what is happening is you're making a motor which is going to have its own mounting points and extra metal to control or host at a particular location. Then you have a 9 to 11 speed gearbox, not required for electric vehicle. Then you have a huge drive shaft starting from the driver and on a 32 feet container truck traveling around 8 meters, 7 meters back of the at the rear axle. There we are connected with a differential and then you are driving the truck. So if you think of overall structure, this is around 400 to 500 kilograms heavier than just taking a motor, designing a gearbox, and attaching it to the differential at the rear end. So that's what we're doing. So it makes our truck lighter, more efficient because we have less moving components and less length to carry about, less angles of rotation for the overall power as well. In fact, the designs we are working on, there the motors are actually parallel to the tires, so there's a very less 90-degree rotations which cause inefficiencies. That allows us to keep the truck lighter and more efficient. And everything what we're thinking is to make sure the truck is more efficient because just launching a truck because we want to hit a date is not what we want to do. What will be achieved if we are the first company to launch a truck in the market where it just is not efficient.